Greetings, universe explorers. Welcome to another exciting episode of Investigating the Universe. We're here to unravel the mysteries of the cosmos, one question at a time. Today's topic is as small as it is vast. We're talking about particles, the tiny building blocks of the universe. Understanding these minute entities is crucial to our comprehension of the universe at large. So buckle up, because today we dive into the microscopic world of particles that make up the vast universe we live in. When we talk about particles, what exactly do we mean? Well, in the simplest terms, particles are the tiniest units of matter. They form the basis of everything we see, touch, smell, taste, and experience. From the screen you're watching this video on to the vastness of the cosmos, everything is made up of particles. Firstly, let's talk about atoms. Atoms are the basic units of matter and the defining structure of elements. They're composed of three types of particles: protons, neutrons, and electrons. Protons carry a positive electrical charge, electrons carry a negative charge, and neutrons have no charge at all. These particles come together to form an atom, with protons and neutrons forming the nucleus, and electrons whizzing around them in a cloud-like formation. But atoms don't usually exist in isolation. They bond with other atoms to form molecules. A molecule is the smallest unit of a substance that retains all the physical and chemical properties of that substance. For example, a molecule of water is made up of 2 hydrogen atoms and 1 oxygen atom. Now let's delve deeper into the world of particles. Subatomic particles, as their name suggests, are particles smaller than an atom. Protons, neutrons, and electrons are the most well-known subatomic particles, but there's an entire zoo of other particles out there. These include neutrinos, quarks, and bosons, each with their unique properties and behaviors. How these particles interact with each other is what forms the world as we know it. The forces between them, their movements and transformations, all these processes shape the universe and our everyday reality. From the chair you're sitting on to the stars in the night sky, particles and their interactions play a central role. So particles are the building blocks of the universe, each one playing a vital role in shaping our reality. They are the foundation of everything we see and don't see, the seen and the unseen, the known and the unknown. And as we continue our journey into the universe, we'll discover more about these fascinating particles and their mysterious world. Now that we understand what particles are, how many of them exist in the universe? A question that might seem simple, but in reality, is anything but. When we attempt to estimate the number of particles in the universe, we tread into territory that is both awe-inspiring and humbling. Scientists have made some educated guesses, and the numbers they have come up with are mind-boggling. If we consider particles to be atoms, then estimates suggest there are around 1 vigintillion atoms in the universe. That's a 1 followed by 63 zeros. A number so large it's hard to even wrap our minds around it. So how do scientists arrive at such astronomical estimates? Well, they start by calculating the number of atoms in our own galaxy, the Milky Way. They estimate the mass of the galaxy, make some assumptions about the average mass of an atom, and then do some number crunching. Once they have an estimate for our galaxy, they extrapolate that to the estimated 2 trillion galaxies in the observable universe. But this process is far from straightforward. Scientists face significant challenges in making these calculations. For one, they must grapple with the fact that not all atoms are created equal. The mass of an atom can vary depending on its element, which adds a layer of complexity to the calculations. Moreover, we're limited by what we can observe. The universe is expanding, and there are parts of it that are simply out of our observable range. That means there are likely many more particles out there than we can possibly calculate. And let's not forget about dark matter and dark energy, mysterious substances that make up about 95% of the universe. We're not sure what these are made of, so they add another dimension of uncertainty to our particle count. The sheer number of particles in the universe is staggering, a testament to the vastness of the cosmos. This vastness, this complexity, is what makes studying the universe so fascinating. Each particle, each atom, is a part of the grand cosmic story, contributing to the infinite mystery of our universe. Why is it important to understand particles in the universe, you might ask? Well, the answer is as vast and complex as the cosmos themselves. Particles are the building blocks of the universe, the smallest pieces that make up everything we see and don't see. They're like the minuscule Lego bricks of the cosmos, forming your morning coffee, the air you breathe, and even the stars in the night sky. By studying particles, we delve into the world of the infinitesimally small, where the fundamental laws of physics hold sway. Here, we encounter phenomena so strange and counterintuitive that they seem to belong more in the realm of science fiction than fact. Quantum mechanics, antimatter, dark matter, these are all concepts birthed from the study of particles. But the significance of particles doesn't end with simply understanding the universe's building blocks. It also extends to the origins of the universe itself. The Big Bang, the event that kick-started the cosmos, was essentially a particle party, with particles colliding and interacting in a fiery dance of creation. By probing particles, we get a glimpse into the universe's first moments, letting us piece together the cosmic jigsaw puzzle. Particles also play a crucial role in our everyday lives. They're not just esoteric concepts confined to the chalkboards of physicists. The study of particles has fueled advancements in technology and medicine. Particle accelerators, for instance, are used not only to explore the universe on a microscale, but also to treat cancer through radiation therapy. The semiconductors in your smartphone owe their existence to our understanding of particle physics. So when we study particles, we're not just indulging in academic curiosity. We're exploring the fundamental nature of reality, peering back in time to the birth of the cosmos, and driving the wheel of innovation that improves our lives. Unraveling the mysteries of particles brings us closer to understanding the fabric of the universe itself. How do scientists investigate these tiny particles, you might wonder? The world of particles is a realm of the infinitesimally small, and yet it's a universe in its own right. To explore this microcosm, scientists employ a variety of tools and methods, some of which are as fascinating as the particles themselves. One such tool is the particle accelerator. Think of it as a cosmic racetrack where particles are sped up to nearly the speed of light, then smashed together. The resulting collision gives birth to a multitude of other particles, offering clues into the very fabric of existence. These accelerators have evolved over time, from early cyclotrons to today's gargantuan structures like the Large Hadron Collider. Then, there's the realm of quantum physics. This branch of science delves into the behavior of particles at their most fundamental level. It's a world where particles can exist in two places at once, where they can be both particle and wave, where the act of observing can change the observed. Quantum physics has been instrumental in understanding the nature of particles, and it continues to evolve, making new discoveries and challenging our understanding of reality. Scientists also employ computer simulations to study particles. These simulations model the behavior of particles under different conditions, allowing scientists to make predictions and test theories. Over time, as computing power has increased, these simulations have become more complex, capable of modeling incredibly intricate systems of particles. Finally, there's the method of direct observation. Scientists use powerful microscopes and detectors to observe particles. This method has evolved significantly with the advent of technologies like electron microscopes and cloud chambers. The investigation of particles is a fascinating journey, one that continues to push the boundaries of our knowledge and understanding. And as our tools and methods evolve, so too does our insight into this tiny yet vast universe of particles. The journey is far from over, and who knows what incredible discoveries await us in the realm of the infinitesimally small. As we conclude our journey into the world of particles, let's take a moment to reflect on what we've discovered. We started by defining particles, those tiny building blocks of matter that make up everything in our universe. Then we delved into the sheer number of particles in the universe, a number so vast it's hard to comprehend. We examined the significance of particles, how they interact with each other, and how these interactions shape the world around us. We also explored how particles are the key to understanding the universe and its mysteries. Whether it's the particles that make up the stars and planets, or the elusive dark matter particles that hold galaxies together, each particle has a story to tell. Finally, we discussed the ongoing investigations into particles. Scientists around the world are using cutting-edge technology to study particles, trying to unlock the secrets they hold. Every discovery brings us closer to understanding the universe and our place in it. The world of particles is fascinating and complex, and there's so much more to learn. It's a journey that's far from over, and we invite you to continue with us. Thank you for joining us on this exploration of particles in the universe. Remember to subscribe to Investigating the Universe and give this video a like and share. Stay curious and keep exploring the universe.